Good evening, everyone. My name's Tom. I'm a Director of Engineering at Redbubble. As I said, we're hiring. Come talk to me. What I want to do tonight is give you an introduction to GraphQL. You're not going to walk away being an expert on GraphQL and understanding all the ins and outs and everything about it, but you should at least have a very superficial overview such that you can go and actually read stuff about GraphQL and learn something without being completely confused about what it means. By the way that I said GraphQL, you can see I'm not from Victoria, I'm from Queensland, so I'm going to keep saying GraphQL rather than GraphQL. I apologise for that, but it's the way it is. It's a thing that I've noticed since I moved here. It's really weird. It's like pool, you say pool. Anyway, there's lots of them. There's lots of regional variations. To give you some context for how we came to GraphQL, we were building out a new native mobile app. And here's some screenshots of the app. This is from this afternoon, so they're reasonably up to date. And we were basically outside of our monolith. Lots of people probably have monoliths, single code base. Ours is a Rails monolith. We have lots of other satellite services around it, but in general, most of the functionality is within our monolith. And we had the flexibility of doing stuff outside of our monolith, and in fact, we wanted to use that as an architectural style. You may have heard this called a backend for a front end or a BFF. If you're as old as I am, you've probably called it a proxy API or a gateway API or something like that. So we're effectively just building a service that abstracts a bunch of back-end services, 17 currently. The developers that were on our team were mainly Swift developers, and we didn't have anyone on the team with any Ruby experience. So keep that as context for when I'm talking about stuff. I'm not going to say GraphQL is awesome. It is pretty good, but just keep it in the back of your head as to what sort of situations you may or you may not use it for. We were doing lots of customer testing at that time, lots of, going in, user research, talking to our customers, getting people in the office, doing remote testing. And we'd started using React Native as a tool for doing that testing. We'd started off with InVision prototypes. We moved to the Facebook tool that I've forgotten the name of, that's based on the Apple tool that I've forgotten the name of as well. But we eventually moved to React Native. And if you've ever done any React Native, it's got really good support for GraphQL. So we managed to spin up a really simple endpoint inside of our monolith and expose a bunch of our data via GraphQL. And it was a really, really great way to get going and get started. And one of the main problems we were trying to solve is, as a team, how do we iterate fast enough to do those customer testing and to work really fast with our designers while still exposing the data that we needed. And GraphQL was a great way to do that. I give you all of that context just so that you walk away understanding kind of the rationale behind what I'm saying. So now that's out of the way, assuming I've got a list of products, that's a line of Scala. I apologise for that, but it's showing effectively that we've got some list of products. We want to expose that via an API. So here's a really simple HTTP API that does a get on some products. So that's something that we do a lot. And one of the things that comes out of that is like, what things do we want to return in that API? Does it need to be big? Does it need to be little? Do we just want some basic details? Do we want the whole subset of what goes into a product? How do we know which set we want, and how do we know when? What happens if we want some of the details in one area and more of the details later on? There's no way of being able to do that via an API like this. So consider this response. This is a subset of a Redbubble product. This is a product API that we built as part of this project. And there's a lot of data in here, right? This is just one of our products. We have about 65 products. So if you're asking for products for a particular artwork, then you might get back a lot of information. So let's just zoom in on one of these. This is our artist information. So what if we want to display the artist information? So you might have noticed the screenshot before. There was a little tiny circle avatar with an artist picture in there with some information about the artist. We wanted to be able to display that stuff. In here, we've got a whole bunch of detail around that API. We've got their username, their avatar, their profile, where they live. But what if we have another API, which we do, that takes an artist username, which is their identifier, and returns back their details? So should we return an artist username there instead? But that means we'll have to make two calls, and we're building a mobile app, so that's really wasteful. So should we do something else? We can go through that same thought exercise for all of the other bits of functionality that are within this product. So the same goes for price. What if we don't need a price? Our first release of our app, we didn't support multi-currency, so there was no need to have the currency in there. It was always Australian dollars. The same thing if we're just displaying a simple list of like the title and you want to be able to click through and see the details. We don't need all that other stuff. We've gone through lots of things that are wrong with that product, but what we're really saying is that API is fixed. We have no choice in how that API works because the people that are building the API have defined that for us. Now, in some organizations, that's how you work. You have API teams or backend teams or whatever. We don't work that way. We don't think that's very productive or efficient. So there are alternatives to this. So let me give you a concrete example of GraphQL. On the left, we have something, I think it's from SoundCloud, and it's about fetching, or it could be from Spotify, fetching artist details. So here are two REST calls. We go and we get the details, and then we go and get the comments that are associated with each of those albums. On the right is the equivalent GraphQL query. So we're making a single query and we're specifying all the details we want up front. This is the query information here, which we'll see in more detail later. And then the structure of the response matches the shape of the request, which is another really good thing about GraphQL. So I've kind of ranted about some of the issues that were in that product API. So just to enumerate what they are, there's a whole bunch that we have with kind of traditional REST APIs. We have that overfetching, so getting too much data, underfetching, so not getting enough data for what we want to display in the screen, multiple calls to get that same information. I was talking to someone in the break, we built a search API that returned a whole bunch of information, most of which we didn't want a few years ago. And we also had another API that returned something. We had a search API that returned work information, and then we had to look up that work information. So that search API returned 96 results. And for each one of those, we had to make a subsequent call to get the details. So we were making 97 calls just to populate one screen. That's really inefficient, right? We fixed that API. But that kind of just shows the problems that are associated with REST if you're not careful about what you're doing. There's also issues around type safety. So when you're integrating with an API where you don't know what it's returning, sometimes APIs, I don't know how much API work you guys have all done, but sometimes APIs return XML, sometimes they return JSON, depending on when you call them, which might freak you out, but that's a real thing. Sometimes they're not consistent in their error responses. You don't often know whether something's going to be a floating point number or an integer, if it's always going to be a string, maybe it's going to be an array, maybe it's going to be a hash. In different circumstances, you might get different representations of the same data in different ways, even from the same API. So the standards and the type safety around that, knowing the information you want to get back are quite weak. There's also this thing about not having documentation. There are tools around now that help you with this. So Swagger is one of those tools that helps you, but they're kind of just bolted on the side. And probably the biggest thing that you'll run into is, as I said earlier, is that the API is fixed. Now, there are solutions in REST. I don't want to kind of say REST is crap because it's awesome. There are solutions in REST. Here are two of them. This is from Facebook and Google. These things exist and have existed for a long time. I did a project in 2003, I think it was, where a guy used bit masks to return fields in a RESTful API. So these things exist, they're available, they've been around for a long time, but there's really no consistency to them. So now that we've kind of bagged REST, let's talk about GraphQL. GraphQL, as I've kind of been alluding to, really what it does is it inverses that client-server relationship. So rather than the server just giving you what it thinks you need, you ask for what you want. So this leads to solutions for a lot of those problems that we've talked to earlier. Not all of them, but a lot of them. So what is GraphQL? It was developed at Facebook. It was used internally since probably 2012. If you've got one of these and you've used any of the Facebook apps, you've used GraphQL. All of their apps are built on top of it. It was open sourced in 2015, and there's a bunch of different implementations for a whole bunch of different programming languages. The one that Facebook ships as the open source or the reference implementation is based on Node.js, but there's a whole ton of them. There are ones in Ruby. Any language you can pick, there's a GraphQL implementation, both for server-side as well as client-side. So I heard someone talk about Elm before. There's really good GraphQL bindings in Elm. It's also an open specification, so all of the development and all of everything that goes on with the project is out in the open. There's some really fundamental design themes in GraphQL. One of them is that it's front-end centric, so this is that inversing that relationship thing. So it's really about giving the power to the client developers to specify what they want from the back end. And by that I mean these client-specified queries. You can ask for the things that you need at the time that you need, and they could be different over time or they could be different in different screens. For our use case, you might be asking for a list of a list of products on one screen and then you click on it, you might get a different list of products. So you want to be able to change the thing you're asking for depending on which screen you're in the app. It's hierarchical. GraphQL calls these things fields, so they're nested hierarchies. It's structured. You can execute arbitrary code at different elements within your query, and that might sound really freaky, but I'll show you what that means in a sec. It's an application layer protocol, so it's transport agnostic. It doesn't talk about transport, it doesn't care about JSON, it doesn't care about protobuf, it doesn't care about HTTP. It's also strongly typed, and that's a fundamental design principle within GraphQL, which makes it really great if you're using a strongly typed language. It also has and I've kind of put this little caveat here, it has a backwards compatibility story. It's not awesome, but it's not crap. So you've still got to do some work to make it work, but it does have the support for things like deprecating fields and giving detailed instructions as to what to do. It's also introspective, which is probably the best thing about it when you're using it for real. You can kind of point it at a server and you can get tools that will point at servers and they will generate you the schema and the documentation, and you can interactively build queries, which I'll show you in a minute. So when you get started using GraphQL, you'll kind of be inundated with all this stuff, and it's really, really hard to figure out what is GraphQL, what is the reference implementation in Node.js, what is something else. It's really hard to figure that out. So GraphQL is really just three things. It's a simple type system, and by simple I mean strings, integers, booleans, numbers, things like that. And it's a schema, and the schema is basically your domain represented using those types. So we talked about products before. Products might have a URL, and a URL is a string. So that's a schema. And then there's a query language, and that query language is custom to your schema that lets you get at the data that you're exposing. So what isn't it? So this is probably the biggest thing that you might need to take away from this if you go looking at GraphQL. It's not a runtime to execute the query. So we use Sangria. There are a bunch of different bindings for various languages. It's not the runtime. It's not an encoding mechanism. All of the examples you see are JSON, and they're JSON over HTTP. That's not GraphQL. That's just the server that you're running GraphQL on. So I kind of touched on this. It's not a transport. It doesn't care about HTTP. It's not client-side bindings. So there are lots of client-side bindings for building apps using GraphQL servers. That's not GraphQL. They're just bindings for GraphQL servers. It's not the tools that ship with GraphQL. It's really interesting. I think of GraphQL as being the tools in my head conceptually. It's GraphQL, which is the web-based interface, but it's not that. But you just get so used to doing it that you kind of conflate the two things. And it's not a server, which might freak people out. Like, it's not a server. It's just the schema, the query language, etc. And it's also not tied to a data store. So it doesn't care if you've got a database. We abstract it on top of services, so we don't even have a database. Our service is completely stateless. So it doesn't require you to have a database, and it's not a graph database language. If you've done any graph database work, it's not that. So having worked with it for about a year, what are the killer features? Probably the biggest one is that you can model your domain. So for us, we've got a bunch of disparate systems, and we want to kind of present them as a facade, as a single unified thing to our mobile app. So we can say, this is what the Redbubble domain looks like. These are our works, these are our products, these are our artists, this is how they relate together. We can do that in GraphQL, and you can introspectively and interactively build up that model of what you're looking at and query that data. It's got great introspection tools. The documentation is awesome. You can get at your schema. You can see what those fields are. You can see what they're for. You can see valid values like country codes, for example. It's also got types, which is really fantastic if you're integrating with a foreign API and you want to know how it works and what it's doing. And this is the biggest thing that I found was unexpected for me. It's really, really simple to add new features to the API. You can just really quickly knock things out, and they're consistent. So if we represent a product in our search results and we represent a product in a feed, like a personalized feed, they're the same product. We don't have to define that thing twice. We're not querying it from different APIs and getting different results. It always has the same fields. Always. So let's give a demo. I'm going to start my server. So I've given this talk a couple of times in Sydney, and it's really good if you have questions to just interrupt me and yell them out. Normally, me ranting versus you questioning the questions are much better. So feel free to ask a question. Yeah, it's awesome, isn't it? So now I'm going to really confuse myself because I don't have it on. Oh, there it is up there. Hang on a sec. Question. That's not a question. Okay, so what I'm going to ask you guys to do is to give me an artwork, and I'll make that bigger if I focus it. Cats, where's cats? That cat? Oh, that's that one. That one's more colourful. Okay, so I'm going to grab this work ID, and then I'm going to go over here. Yay. All right, so this is GraphQL. I'll make that bigger. If I make it too big, it messes up the formatting, so I apologize in advance for this. So this is GraphQL. This is a thing that ships. You can go and download this from, I don't know, github.com/Facebook/GraphQL, or whatever it is. It's written in React. It basically points at a schema and it sends it an introspective query. And that basically says, tell me all of your types and how they relate. So tell me your schema. And then it builds a really nice interface based on it. So we've pointed it at our server and we have two different APIs. We've got a query API for read access and we've got a mutation API for write access. And we can go and look at that. So we can have a look at some of the things that we expose. So here we can get the details of an artwork. What parameters does that take? Well, it takes a work ID and a country and a currency code. And it returns us a work. That's awesome. What does a work look like? Well, a work has a title and a work has an image. What does an image look like? Well, an image is a URL and a size. Great. What's the size look like? So you can see you can start to interactively build up what it is that you're looking at, and you can get an idea for the kinds of things you can get back from the API. So I'm going to jump over to my other screen, and I'm going to grab a query. I'm going to close this. And I'm going to put in that work ID that we saw earlier. So hopefully this works. Yay. Okay, so this is hitting the server on my machine, which is going out and talking to backend services across the internet. So what we've asked for is the available products for an artwork. So we print artwork on products, and we've said, given this particular artwork with that identifier, go out and find me those products. So I've asked for the type name, which is effectively a human readable string of the thing. So there's a graphic t-shirt here. Let's go and ask for some more things. Let's see how much it is. I'm just control spacing through this. It has an amount, it has a currency. Okay, so a graphic t-shirt is $29.50 USD. If I change that to Australia and AUD, I should get back a different currency. So it's $36 Australian. I'm just going to remove that to some other stuff. So what I really want to show you is kind of the images. We should have a URL. So you can see I'm just introspectively building this up. I'm just playing around with the schema and just control spacing. You can't see me in control spacing, but I'm control spacing and hitting enter and tab. And it just lets you build up that query. And it's really great as a client developer. So that's the thing that we saw earlier. On a graphic t-shirt, yay, awesome, it works. So it's really good if you're a client developer and you're looking at a foreign API and you just want to figure out how do I integrate with it without any guidance. You can just kind of interactively build that up and then you can take that query and do something with it. Like in our mobile app, we have them in a bundle and we use them to send queries up to our server. You know, you could do whatever, stick them somewhere and use them. You can do other really interesting things with GraphQL. So we can ask for 2 products back as well in the same query, which might sound weird. So you can specify more than one. These are called fields, and you can specify more than one field. So I'm going to grab a different work ID from over here. And I'm going to alias these things. So there's product 1 and there's product 2. I might ask for different things maybe. And just to show you that it's actually working. So there's the second product with different things in them. So you can do some really interesting things with that, and that's going out and doing all the right things on the back end and making it all work. Some of the other things that's nice with GraphQL is that you can get this kind of inline error messages. So let me try and push this over. So I don't know if you saw before the red squiggly. Let me try and get the red squiggly up again. That's probably too hard for it. So say I misspell something. Well, the first thing you saw was that as I type things, I get like an autocomplete list of the things that match that. So it's a bit like an IDE. You can kind of drill through things. And then if I misspell something, I get this little red squiggly, and it gives me some really, really nice information. If I go and execute that query, I get some other really nice stuff. So I get consistent formatting of errors. I always get back an errors array. It's always an array. It's never a hash, and it always has a message. So you can rely on that consistency for the error messages. GraphQL does some other interesting things. If you've been around long enough to have integrated with Microsoft SOAP-based web services, they used to often return 200 response codes, someone's smiling, 200 response codes when they should have returned 400 or 404 or 500 even. GraphQL actually does that, which freaked me out when I first built the integration with GraphQL, and I actually made it more RESTful. But the reason they do that is because it's built for things where you have partial responses. So to give you an example, say you're looking at Facebook and you're looking, say I'm looking at Toby's profile and I want to see his friends, then maybe I can see his friends, but can I see their friends? So you can recursively query this data, but at some point there's going to be a block, like one of those friends might have blocked access. So I'm going to get a partial data back. I'm going to get Toby, I'm going to get some of his friends, but maybe I can't see their pictures, or maybe I can't get their friends. So in that case, you'd get back both a data element as well as an errors element. So the data would let you represent the data that you're actually allowed to see, and the errors element is everything else. So GraphQL, the HTTP stuff for GraphQL, which is more a convention than a standard, kind of lets you do those things and plays bizarrely with kind of REST-based protocols. Just to show you the introspection query as well, to show you that it's not garbage. So this is the introspection query. All the introspection queries start with double underscores. So I've asked for the information about the thing called product category. I could ask for other things. So we saw a work before. So a work is an artwork created by an artist. And these introspection queries are what let us power and build that documentation. There's no magic there. It's just running the query and then parsing it and displaying it. And then there's some UI goodness built on top of that to let you browse through it. So you can start to get information about what fields does a work have? Okay, it's got a title and an image. Okay. So what is their descriptions? So you can start to do that yourself if you so care. I'm not sure why you would, but you can do that. And tools are built on top of this that make use of this functionality. So you've seen me build up a query. This is a really simple query. This is a product query that goes and looks for, firstly gets back all of our products, and then for each one of those products gets the URLs for them. And the response of that looks the same shape as the query. So if you come back to the query, a product has a URL, a product has a URL. And it's always the same structure. There's always a top level data element, and there's always the things that you've asked for. If I change the name of that from product to P1, like you saw earlier, the name of it in the response would change as well. So those things are called fields that I'm querying, and you can kind of hierarchically or recursively build those things up. And the whole thing's called a document. So the thing that I've kind of been anecdotally referring to the query is actually called the document. These fields are really interesting. Fields can be nested. Fields can have names as well as arguments, and they also have return types. So you've obviously done some programming because you're here. They're just like functions. So you can think of fields, analogously with functions, and the body of the function is called a resolver in GraphQL. So if you're thinking, what is a resolver? It's just the body of the function. How do I go and fetch the thing that field is asking for? You can also use parameters in your fields, as I talked about. So this is saying, I've got a query. You can name your queries. This is an example of a name query, a product with an ID of 1, and get its URL. So you start to build up this nomenclature around that. So these things are called arguments. You can call them parameters if you want. and the whole thing is called an operation. You can start to parameterize your operations as well if you want to, which is really great if you've got like canned queries. One of the things that is, I think it's just been standardized in GraphQL, is that you can essentially issue GET requests against the GraphQL server, and you can pass those parameters in your query string. Normally, GraphQL servers expose their data over posts, so it's not really great for caching and things like that. But what you can do is you can reference essentially a named query on the server, and you can pass the parameters, and then you can fill them out here. So that's another great thing with GraphQL that I think has just been standardized. And the way that you pass your variables if you're issuing a post request over HTTP is you just pass a JSON array. It's that simple. You can also specify mutations. So this is a mutation hypothetically that adds a product. So this is given a name. That mutation keyword basically namespaces, and there's no magic behind that except you're saying I'm now in the mutation namespace, and that basically just gives you a different parallel world into your schema. There's nothing more than convention beyond issuing read versus write queries. There's no tooling that's going to stop you making actual mutations or performing side effects if you do queries. But it's a nice way to segregate your schema into reads versus writes. And you might apply different semantics on top of that. So maybe your permissions are different. Maybe you apply different, you can set boundaries around how often you can recurse or how far you can recurse. You might issue those things differently depending on whether you had reads versus mutations. So this is adding a product. We've got an input argument here. And again, we're adding a product with an ID of 2 and a URL. And the thing with queries, with mutations, is that you can ask for the data back again. So when you've made that query, you can ask for the data back again. The same things apply for mutations as for fields. I've already talked about this. So you've probably heard me say things at the start like, it's not HTTP, it's not a server, and then me say it's JSON or it's HTTP. What I basically mean is that you have to build your engine on top of a server and expose it somehow. This is a really simple kind of tying everything together example. This is just a simple curl that goes and issues a post. As I said, most GraphQL servers, when they expose their data, they do so over HTTP and they accept posts. And you essentially specify your query and all the information about it as a JSON payload. So here's our query. It's the one we saw earlier. We've passed some variables. We've also passed an operation name. You can embed multiple queries in your payload, and then you can differentiate between which one you actually want to execute by putting that name in there. I don't know when you'd use that. We haven't used that, but it's something you can do. And then you'll get back a 200 and you'll get a JSON payload in response. All right, how am I doing for time, Toby? I'm okay. Do you want me to show you more examples? Do you want me to keep ranting? Up to you guys. I've got lots of stuff about schemas, which is really dry, and types and all sorts of things. Have we? No, but you could. You definitely could, and they could dynamically change. So the question was, have you ever built forms based on the schema? We haven't personally, no. We just effectively use it as an API to our backend system that lets us kind of aggregate across disparate systems. So we have, for example, a system that returns artist names, and a system that returns delivery dates, and a system that lets us do searches. And we can aggregate those things together and tie them into one, Redbubble data model. And that's the thing that is really great about GraphQL. And those things are actually, at runtime, having live queries executed and multiplexed across those backend services and returned. So no, we haven't done anything like that, but you definitely could.
What about performance? Is there any significant performance by using this?
Interesting question. Is there any performance when using GraphQL? Let me paraphrase your question. You can kind of brute force attack GraphQL servers. There are ways around that. So for example, if you're Facebook, you might ask for, I'm going to pick on Toby again, Toby, and then his friends, and then their friends, and then their friends, and then their friends, and so on. So you can set up these recursive queries. There is no limitation in the schema for that per se. So by virtue of the fact that you've got a person and they have friends and those friends are people, you've set up that recursive structure. You can, however, set up in the tools, the execution engine of the GraphQL server, you can set up constraints around that. So we have a thing that says don't allow recursing more than 9 levels deep. It's 9 because that's what the introspection query is. Not because we use it, but because we want to run those introspection tools. So you can put boundaries on that. The framework that we use as well allows us to set performance costs on things. So we can say things like going and fetching related works for a particular artwork, which is effectively doing like similarity searches, is, I don't know, I'm just going to make up some numbers, of cost 1, and going and doing a search is of cost 2. And you can essentially look at a query in aggregate and say, okay, that's cost 3 in total. And you can put limitations on that. So you can say, don't allow queries more than of cost X and prevent those things. In terms of actual raw performance, we've load tested this thing up to about 95,000 requests per minute. I was going to say per second, per minute on my laptop at work, generating the load as well. So it scales pretty well. We have heavy caching in there though. That's not a real world performance. That's just executing the same query over and over again, 95,000 times basically. It's actually 25,000. And you can set up lots of levels of caching. We have 2 levels of caching in the API. One of the things that it doesn't do easily is because it plays with posts rather than get, it makes it harder to put a CDN in place. We don't have a CDN in front of the server. So that's a thing that you might have trouble with if you wanted to do something like that. It hasn't been an issue for us because most of our requests are different and they wouldn't have been cached by the CDN anyway. So yeah, we cache low-level objects like products and artists and things like that. We don't really cache at a higher level. I'm not sure if that answers your question.
Is there any other companies using the same thing?
Lots. Big corporations, GitHub. GitHub's public API is now GraphQL. BuildKite, which is a local Melbourne company, their public API is GraphQL. Who else? We have 3 services, 2 of which are currently in production that use GraphQL. A third one might be being built soon. I talked to the engineering manager yesterday and he wants to use it. So I don't know anyone else in Melbourne using it. There you go, Melbourne University. Facebook, the GraphQL GitHub page has a bunch of companies that are using it. You can see all of them. There's tons. There's lots of them.
What was the process like of building up the knowledge internally about it? Did you bring in somebody who'd done it before, or did you sort of?
We kind of fell into it. We had a guy who a lot of you might know, Anthony Mitaz, who did some work on the front end for us, and he started using React Native, and then he kind of, through him, we fell into GraphQL. And when he was contracting to us through Cogent, and when his contract ran out, we all got into it as a team, and it really helped us with prototyping. We're probably at a point now where the thing that we're doing is mature enough that it's kind of at an even level as to whether the benefits outweigh the costs of GraphQL, to be honest. If you were going to build a public API for a bunch of disparate users that you didn't know what they were doing, then I think it's a really good choice. If you were doing server-to-server comms, then I wouldn't use GraphQL. It just doesn't make any sense. If you've got tight coupling between the client and the server, then it probably doesn't make a lot of sense. So we now have, a lot of apps out, but we have a pretty high adoption rate of the newest app. It's like at 97% or something. So we can deprecate fields, keep them running for a couple of months and then move on if we want to. We haven't, but if you've got that tight coupling, then I don't know, it's kind of debatable. If you ask our client devs, they're not that happy with GraphQL. It doesn't give them a lot more than what just a straight RESTful service would do. They get the interactivity, so they can query a server and they can get the data back and they can build their things. But once they've built it, they stick it into their bundle file and then they just send it and they parameterize the queries and that's it. And they're done. Like they don't build things dynamically or anything like that. So I think it makes a lot of sense for some use cases. So public APIs, things where you don't know who's going to be calling it. So we've had designers, for example, come and talk to us and say, I want to mock out some new prototypes. Can I use your endpoint? Because it gives them kind of a window into the world. And there's lots of great tools that let you build prototypes based on GraphQL. And they can do whatever they want and they can present the data in ways that we wouldn't think of as the API providers. Not sure if that answered your question. Question over here?
You mentioned earlier about, I guess, not wanting to make multiple calls for
Yep.
So you make a single call for GraphQL, so then GraphQL
Yes.
makes multiple calls.
Yes.
I guess then the only benefit would be
So there's probably, yep.
Repeat the question.
Sorry, thank you. So the question was, I mentioned before about not making multiple calls from the client, but the server's making multiple calls. So what are the benefits of that? So there's probably a couple of things. One is this, you can probably assume that the server-to-server comms are on a faster network than an iOS app in a basement of a building. You can probably assume that the latency is lower on those server-to-server connections. You can probably assume, in our case, that they're in the same data center. So you should get a faster connection with lower latency. So that's probably the first thing. The second thing is we have two levels of caching. We have a pure request response GraphQL cache. So if you send the same query, we'll serve the same response from memory. We have an in-memory cache. You can put it out wherever you want, but it's an in-memory cache currently. And we also have a low-level cache. So if you ask for what we call our found feed, which if you go to our website, there's a whole bunch of things on it. That's our found feed. They're curated things that our curators have found. Lots of people ask for those things. So all those things are cached. So the products, the artworks, the artists, they're all cached. So if somebody else comes and, I don't know, I'm just going to make this up, but let's say I looked for the, I don't know, Christmas kids collection, and then somebody else came along and looked for the Christmas adults collection, and there was an overlap of artworks, we'd serve that overlap from the cache. So we've got fairly heavy caching in that. We don't get a great cache hit rate. It's about 15 to 20%, but it's better than nothing. The third thing I'd say is that the libraries that are available for doing that work are far more sophisticated, I think, on the server than they are on the client. With Swift, that's kind of changing, and you've certainly got newer languages like Kotlin that give you, and you can do things like Scala on Android as well. So there are lots of tools that are available for you, but I think in general it's more well known, the kinds of tools that you can use, like the asynchronicity that you can make use of on the back end. So lots of the GraphQL servers employ like actor frameworks, for example, to do that. We don't use that personally, but there's lots of tools that are available that let you do that multiplexing in an efficient way and deal with errors and stuff like that. So, for example, if one of our backend services goes down, we have really fine-grained alerting around that. We monitor metrics. We know when it's happening. We can monitor elevated error rates and things like that. You could probably build the same on the client, but maybe it's a bit harder. I don't know. It just made sense architecturally as well to have a single API that we talk to rather than trying to multiplex across many, because then we've got that level of indirection so that we can, you know, when our search guys build out a new search API, we can just switch over to it and it's done. We don't have to go and try and go and update all those apps that were there previously. There was a question over here, Matt.
Yeah, how do you go about
Pre-baked queries. So the question was, how do you build the queries on the client side? You're probably better off asking one of our iOS devs, but I'm going to answer for them. We essentially, if we make any new server changes, what we do is we embed the query and the differences in the pull request. So we'll have the pull request and we'll give an example query and example response. So that kind of gives them like a heads up as to what we're doing. And then we'll copy that pull request into our Slack channel so that they're aware of what it is, or we'll add it to the Trello card or whatever it is. So that gives them a start for how they might go about querying it. My understanding of what they actually do is run the server. We like to have generalist developers. So all of our developers are doing what we call N+1 stacks, which basically means if you're an iOS developer, you're picking up one of our other stacks. So for an iOS developer, that's going to either be our Ruby API or our Scala API. So you're picking up those stacks. So most of our iOS devs can work across those stacks anyway. So they might have been the one making the change in the server, sending it as a pull request, and then making the client change and taking that feature all the way through. But yeah, my understanding is they just get in GraphQL and they just interactively type out the query. They copy it into a bundle file, and then they just read the bundle file at runtime and drop in the parameters, substitute the parameters. I think it's like as simple as a search and replace. There are libraries that let you do that. There are really good libraries in Elm. There are now libraries that weren't at the start, but there are GraphQL libraries in Swift that are really good. What they effectively do though, my understanding is that because GraphQL queries can differ, so a representation of a product on your server might be the same, but on your, I don't know, details screen versus a listing screen, you might get different information because you don't need as much. That's a pro with GraphQL, but what it means is you effectively have two different representations for a product. So my understanding of those client-side binding libraries is that they let you have those two different representations. I don't know how they work. I've never used them. I think they're statically generated, like you point them at something and you give them the query and they generate the... Yeah, so it's CodeGen was Matt's comment. Yeah, but they're around, they're usable. In the early days, they didn't exist. So we did a lo-fi way, which was we just like squirt strings down a HTTP connection. Like, and it's worked for like 14 months. So will we change? Don't know, probably. It's probably not the most scalable solution, but it works. And it's low tech. Up the back. That's a really good question. So I'm going to answer your question by answering a different question, and I'll tell you why. I was hoping no one would ask me this. So our server's written in Scala. So our initial prototyping was based on the Ruby gems, and we built that into our monolith, but we kind of have this kind of thing at Redbubble that we don't want to build more stuff into the monolith. So where possible, we're trying to abstract it out. The reason we did that initially was so that we could get at that data really quickly for prototyping, because we didn't know what we wanted to extract out. And we had no APIs to work with. So our team was building out the APIs and figuring out what they look like and what sort of data we wanted to get. So it was really trivial to just add a gem and do that. My understanding is it's pretty mature. That was over a year ago, so it's probably better by now. It was really trivial to get up and running. It was really easy syntactically to do that. So now let me answer the question you didn't ask. For the Scala API, there's like an execution engine that is really mature and it's awesome, but there is zero support for integrating that into a server. So at least in a Rails environment or a rack environment, you've got a gem that you can add and everything's kind of consistent. Those things don't exist in other languages necessarily. So we had to write our own bindings between our HTTP layer and the GraphQL engine, and all of the JSON parsing and the response encoding and all that stuff, we had to do that ourselves. So depending on what you pick, the Node.js framework is probably more mature because it's the one that Facebook use. There's really great bindings. One of our teams is using that with a React-based front end. They've built a back end for a front end for their React-based front end. It's really mature. They have really tight coupling. It works really well, apparently. And that's far more mature, I think, than any of the other implementations, just simply because that's what Facebook use. I don't know how it relates externally versus their internal version, but there's a lot of support going into that. And that's actually a confusing thing because you see lots of JavaScript examples and you're not sure what is GraphQL and what's actually in the JavaScript thing, or what's available to me in the Ruby implementation. Don't know.
What do you do to ensure that there's no bugs on your
So the question was, what do we do for ensure there's no bugs? I'm going to say, what do we do to ensure, how do we test it?
because you say that
We don't do that. That's pretty neat, actually. We have multiple layers of testing. So we use what's called a property testing framework to test all our lower level code. So we use Scala check, which is based on quick check, the Haskell version. So we generate basically a massive range of example inputs and we send it to various, it's basically state-based testing if you've done a lot of unit testing, but it auto-generates. There's lots of Ruby equivalents for those, and I think there's even Ruby property-based testing frameworks as well. So we test our lower level code like that. We test some of our higher level code with integration tests, and then we have what I call happy days tests, which execute the GraphQL layer. So they poke it over HTTP and just make sure we don't get any errors back. So we find that's pretty good coverage. I'm going to get a little bit philosophical now and say that if you're doing testing, then you've really got to have a benefit to that testing. So the amount of effort it takes to put into that, you want to see that benefit back. And in the early days, we had no user base, we had no product. So we didn't do a lot of testing because we were trying to get to market really quickly. That's changed over time. We're now doing more testing because we have 90,000 monthly users or something like that. So we're doing a lot more testing, but yeah, that bang for your buck, impact versus effort thing, you should be asking yourself all the time anyway, and it wasn't there in the early days. So if we were to start again with a mature thing, then we would probably do more testing at various different levels, etc., etc. Oh, I don't know. Tell me when to stop. We do some versioning. We don't do versioning at the HTTP level. So if you've dealt with RESTful APIs, we do have like a V1 in the URL. We've never had to use a V2. We do deprecate fields, so you can deprecate fields. When we initially built the app, we had a thing that we called a collection or a feed, and the feed was basically the curated list of artworks that one of our curators had found. And then we introduced a personalized feed. And so we're like, well, what do we call that? Is it a feed as well? So we deprecated the old name and we added collection feed and I've forgotten the name of the other one, related feed, I think it's called, topic feed. And so we deprecated the old thing. Deprecation doesn't mean things fail. It just means when you're interactively building the query, you'll get a little yellow squiggly line and it won't appear in the documentation. So you can't auto-complete it in the GUI and you won't get documentation for it if you browse the documentation. So it effectively hides things. There is no backwards compatibility story beyond that though. So you can't delete fields, the same as in a regular JSON API, you can't delete fields. You have to just add fields and then hope your clients go away. You can put metrics around that, right? So you can monitor how many clients use a particular field and you can log those things. And when it gets to a, acceptable level, you can kill that field. So there are ways of dealing with it. But no, we don't do much versioning beyond just deprecation. And that's kind of a strategy we use for a lot of things too. With RESTful APIs, we add new stuff, for example, rather than remove things. Cool. Thanks, guys.